All right. Well, welcome everyone. I know I have the privilege to be between you and lunch, so I'll promise to stay on track and get us out of here so we can eat some food. But quick introduction about me. So I'm a co-founder and chief product officer at Oak9. So I like to tell my kids I'm young. They keep calling me old. But I am old. I've been around. I'm a software developer by trade, and what I want to share with you today is really, of all the enterprise applications and products that I've built, worked over the years with security engineering to deliver these products securely. I want to share with you the lessons I've learned especially over the last 5 years, as development teams and DevOps teams are embracing infrastructure as code. They are delivering faster than ever before, going from one release every few months to tens of hundreds of releases a day. And the challenges that this creates for security engineering, and what are practical things, what are some key concrete steps that security engineering can take to keep up with this pace and rate of change that's happening in software delivery, and how can they address some of these challenges. So let me take a quick survey here. How many of you have heard of infrastructure as code? How many of you are, okay, fair number. And how many of you are SREs or DevOps engineers versus security engineers or practitioners? No? Like, are you from security house, DevOps, SRE side, security side? Okay, majority are security. Okay, great. So, I'll give you, it seems like familiarity across infrastructure as code, but, I do want to touch on kind of how infrastructure as code is being adopted today and some of the challenges that it's creating for security. And I'll share some of my own experiences of us building a product at Oak9, how we deliver infrastructure as code, how we automate, and the security, how we address security within those changes. So, let's take a step back, right? Application delivery has fundamentally changed, as you all know. I, as a developer, am no longer building my application logic, my business logic, how my components interact through different data access layers and different systems that they're talking to, and then say, hey, my job is done. I'm going to rely on my infrastructure and ops engineers to build me infrastructures, my servers, my compute, my storage, all of these good things, and go deploy the application. That's how we used to do things. And in a way, this created certain guardrails automatically because there was a delay in how, for security to really catch up and say, how do we deliver security for this application? And if we look at how software and infrastructure as code is really changing this model, is now, as a developer, I am not only building and delivering application code, but I'm also delivering infrastructure as code, right? So now if I want to build some business logic for my analytics service, I can do that with a few hundred lines of code. I can spin up a serverless compute like Lambda, spin up an RDS instance, maybe a message queue, and enable an entire analytics service. And I can do all of that in a sprint or two, which 10 years ago, it used to take me a couple of weeks, couple of months. And then I'd have to wait, as I mentioned, for my infrastructure and operations folks to build out all the capabilities that I need to deliver my application. And so we're seeing this rapid adoption, and we're seeing a different way to deliver cloud native applications, right? And when I think about the model, it's the same model of infrastructure as code development that the developers are using in modern life cycles, right? So I can now rapidly build my infrastructure as code and my application code in parallel, maybe at the same time. And a lot of what we're seeing with our own customers at our own organization and across the industry is that infrastructure as code and its delivery is also being owned more and more by the software development teams, right? So I am not only responsible for that application code, I'm also building out my infrastructure as code that I need to build out the new feature capability that the business is asking me for, and managing the entire pipeline. So I'm building, designing it, I'm building it, I'm coding it, testing it, delivering it, and then the operation and the monitoring phases of all that. So, okay, this is really great. Now I don't have to rely on anyone else to build me my infrastructure. So now I can deliver with 100x velocity. If you look at the latest DevOps reports, latest trends, I can move much faster. I can simplify how my architecture is codified and represented, and I can create a repeatable process of delivery. So I can do this because it's all codified. All this is great, right? As a developer, I love it. I can do this very, very quickly. However, there's a however. How do security teams really apply security design, security reference architectures, meet the business requirements to enable security into it, right? So let's take a look at an example, right? So, this is a pretty typical example of a cloud application that you may see, right? I have some static assets that I've deployed over CDN. I have my API gateway, maybe a load balancer in front with WAF and firewalls. I may even have authorizers built in my compute, and then I have my backend services based on some hybrid microservices architectures that I may have. Some may be enabled through serverless compute, other may be through containerized architecture. And then I have some backend data sources that my services are talking to. So this entire architecture can be represented in code today, right? Whether it's Terraform as an IaC or cloud service provider languages like CloudFormation, Azure Resource Manager, Bicep, what have you. And when I think about what this enables is, now if I want to change to deliver a new feature capability, this architecture is rapidly evolving, right? I can make the changes to that code because it's simpler, it's easier to do. I understand the entire architecture because I have a codified representation of it. And so if let's say, for example, that I want to build an analytics dashboard, I can change a few hundred lines or a few thousand lines of code. I can take advantage of cloud service provider capabilities and features that I have at my disposal. And I have 2 young kids, right? So I think about the Lego pieces that they're constantly building things with. And really the cloud architectures are really exactly like that, right? I can now take my load balancer, I can plug in another Lego piece, I can enable a WAF capability on that load balancer, I can take an application gateway, I can apply a serverless authorizer to it, another Lego piece, I can bring in a message queue, all built in for me, I just have to plug and play, and suddenly I have an event-driven architecture. This is great for me as a developer because I am not having to build all these things from scratch, from ground up. That's great, that makes it easy. And I can define all of this in code and enable all of this agility to the earlier point I was making, which is now I can do this in a sprint or 2, right? So it's all Lego architecture is how I like to think about it. But these architectures inherently now will evolve very rapidly because I have this availability and these capabilities at my disposal. So, all right, so why do these architectures evolve? So one example that I already gave is I have new business requirements, right? I have a business asking me for a new capability that I want to deliver. But if you think about how this evolving architecture, this IaC, is transforming how I actually deliver these new features, right? I no longer have to wait and follow waterfall model to say, hey, customer, I will show you when all of this is completed. I can actually build a little proof of value very quickly. I can bring this in front of my customers using mock data and say, hey, here's an example of is this what you were talking about? Is this the feature you're looking for? And as that proof of value gets accepted, then now I may have new security requirements as it gets connected with, and it goes from proof of value into productionized code, right? Because I may have regulatory or compliance requirements. I may have data residency requirements for an app. Maybe I am delivering to a customer in a specific global region like EU as an example. So now I have new security requirements that I need to meet. I may have compliance and regulatory needs and requirements that I need to meet if I'm in my healthcare world or if I'm in my fintech world. And I talked about using message queues. Lego pieces are Lego architectures for cloud service providers. So inherently, I may have new technology requirements because I added this message queue. But what does this message queue fundamentally mean for the security of this architecture? It's great. I added it with 100 lines of code, but how do I deliver security? Where does security apply? And one thing I've noticed is this is the most overlooked part of how rapidly the complexity with this rapidly evolving architectures is, cloud service providers themselves are rapidly changing features, right? I was talking to a product manager for the AWS CloudFormation team earlier this year, and it blew me away. Something I knew, but he crystallized for me is, he said, by the way, Om, there were 3 days last year where AWS CloudFormation team did not make a change in one of the features or services they were providing in AWS. They didn't make change for 3 days. They made changes 362 days. There were only 3 days where they didn't deploy a new release. So think about what that means for the application and the architecture that this application is running on. So now, security engineering also has to manage that churn. So I've talked a lot about the agility and the benefits of infrastructure as code and how rapidly I can deliver and some of the security challenges that it brings. But if you think about it, this code for a single application could be 10 to 30,000 lines of Terraform or infrastructure as code. So how do we realistically expect a security engineer to be able to assess that code and say, oh, I understand where security applies. I know where security controls need to be, what security controls need to be met across these thousands of lines of code. And, how do I really understand how compliance fits in? So this is really a fundamental challenge. Security engineering just is not equipped to keep up, right? The way of delivering security, as we're all familiar with, is just not going to scale in this world. I mean, you can have, even a large security team cannot really be a force multiplier across an entire portfolio of applications. When I talk to most of our customers, what they tell me is like, oh yeah, we're only looking at maybe the top 10% of our applications, and we're only doing security architecture reviews, once a month, maybe once a quarter in some instances, to really understand all of the changes that are happening, how that impacts security. So the trends are, I've talked about the trends, right? The complexity, the size of the architecture, the connectedness of these architectures, right? I'm no longer dealing with tens of different components that are talking to each other. I'm dealing with thousands of different components, features, and services that are interacting with each other. So if I think about the entropy of change, that entropy of change itself is exponential, right? So how do we keep up with that? And many organizations don't want to get aligned to a single cloud, so they're already deploying multi-cloud strategies, and they're building architectures that span across multiple clouds. So now I have a set of challenges that I talked about, times that by the number of cloud that these application architectures are deployed across. And when we talk about the security resource constraints and the skill gap, there's no way to really scale with the same operational model that we have today. And so what do we need? And I'll tell you, as a developer, one of the key things that I want to share with you is fundamentally we have to change the way we deliver security. That much is obvious. But it really starts with security engineering and development engineering having a common shared goal of delivering security together, because security can't scale. And ultimately, as a developer, I'm responsible for delivering and ensuring that security is built in to the changes that I'm making to my architecture design. And this is really a big ask from a cultural shift perspective, right? That is the fundamental and first thing that we need to achieve, is this cultural shift. We need to be able to sort of work together, right? Break down the silos to create that. And, I touched on, security can't deliver the same way we have been delivering. So we need to design security in a way that really fits into the modern development DLC. And we need to, as a developer, if I'm managing writing application code and business logic, if I'm also managing my pipelines and infrastructure as code, then there are a lot of tools that I'm managing, a lot of processes I'm managing. So then I want the security to be able to fit into my ecosystem and my way of doing things, because that will help me and the development teams achieve that agility and actually deliver that security, as opposed to saying, hey, I will add it into my backlog and deliver it as I have time. And I think the most critical point of what we need is the really only way to scale is to embrace security as code, right? Embrace automation. So just the same way I'm building through infrastructure as code my cloud native architectures, how can security embrace automation to really build a lot of these capabilities around security controls and automate and codify those security controls so that they're delivered up front and as code. So, honestly, we can probably talk about culture shift and spend the entire hour talking about that. But I think really it comes down to, culture shift is hard, right? Because we're all used to doing and operating things in a certain way. So it's hard to change how we operate as an organization, as a business unit, as a team. So, one of the key things and a key enabler in culture shift is to be able to really get a buy-in from the leadership team. It's not just a bottoms-up approach. It's really, you need a buy-in from the leadership to say, hey, we do need to break down these silos. Security can't operate in their own silo. Development team can't think about security as not their responsibility and someone else's responsibility. So it needs to be shared. And, we need to drive awareness of, hey, what are the elements of security that a developer or a dev team or a DevOps team should be considering as they're changing their architectures, as they're changing their applications. And that's something that can't be bolt on, right? Hey, I'll think about security later, or we'll bolt it on post-deployment. As I am changing that application, or I'm trying to design for this new requirement, I need to think about, well, how does security apply here, right? So that's around moving away from this culture of fear of like, I can't deliver this feature until I do this security review, security architecture review, and then I'm going to have to make a bunch of changes because my security engineers are going to say, hey, I won't let you deploy until you do these, right? So it's really moving away from this fear of, I'm dreading this architectural review, to how do we have everyone have a seat at the table on day one and say, hey, here are the changes we're looking to make. How do we think about security? So it's about awareness, it's about education, and it's about measuring how we're rapidly changing and what does that mean for security. And I know that as buzzwords go, right, everyone, there's a big trend towards everyone talking about democratizing security. But, the buzzwords aside, right, and I've touched on some of these points, is, when I think about democratizing security as a developer, what I think about is security can no longer be in its own silo. Security needs to really incorporate and include software development and architecture groups in designing security. And at the same time, I need to share, as I mentioned, right, not only the responsibility of security, but I need to own the delivery of security, right? Because again, security by themselves won't be able to scale. And so security is really needs the seat at the table right from the beginning, right as at the design phase. And we need to make sure that as a developer or as a dev team, that I have actionable and applicable guidance in how I actually enable or achieve this security control or the set of security requirements that my security team is asking me to achieve. So I'll give you a concrete example, right? If I'm given a 40-page reference architecture from security engineering that says, hey, go build this, and part of the security control language is you need to enable security relevant logging and make sure that integrity of those logs is protected. That's great. That's a great security requirement. But how do I actually meet that? That is too broad. I don't necessarily know what that means for my architecture example that I use. I have many hundreds of different components. Where do I enable logging? Is it only at the load balancer? Is it at the API gateway? If I enable logging, where does the logs get collected? How do I understand what specifically to actually do as it relates to my infrastructure as code, right? So I want, in a way, a prescriptive, specific, concrete guidance to say, hey, here are all the places in your infrastructure as code that you need to ensure that logging, security relevant logs are collected. Here's how to do it. And here's how you ensure that the integrity of that log or the logs is being protected, right? So it's about actionable, accessible guidance. The second step that we really need to think about from a security design and delivery perspective is we need to really understand across our entire portfolio of applications, what are key common use cases, key common architectures that application and architecture teams are building. There may be containerized architectures that are using microservices-based architectures. There might be serverless architectures. There might be traditional 3-tier web application-like architecture. So if we first understand what are all the different patterns that we're seeing, and then really utilize these patterns to build a reference, codified reference of these architectures to both deliver the common use cases and controls, but also the security controls for misuse cases of these architectures. And then really deliver these design patterns, not as that 40-page Word document, but as code, right? And then I'm continuously working on building that automation that can actually then enable development teams and the organizations to not only gain visibility into whether these security controls are being met, but how can we course correct and build security and compliance right into that. So I talked about build it as code. Great. How do I do that? And why do I do that? So I talked about the complexity of architectures. The entropy is exponential. But what does it mean to actually codify, right? So again, I come from development background, so I think about automation. And when I am doing test-driven development, when I'm changing lines of code or a feature capability, I'm thinking about that fast feedback that I'm getting through test-driven development. So when I change my code, I know exactly that my unit test or my integration tests are failing before I've even committed that change into my code repository. So security as code, we can think of that in the same way. If I codified how I enable logging in my architecture and deliver that as similarly to test-driven development to that developer, to that practitioner who's changing that infrastructure as code, and I deliver that at the point of time when it's changing, now I'm starting to take advantage of this automation to deliver this security. And it's not just about, as a starting point, looking at simple misconfigurations is good, but holistically what I'm talking about is really codifying the entire architecture, right? So I have this solution architecture of hundreds of components talking to each other, and what's really critical and key is to codify the entire architecture through code to deliver that security, right? So now it's not just about, hey, enable encryption at rest. That's great. That's a good starting point. but then continuously improve to say, you've enabled encryption, but are you using the right key management system to actually build that encryption? Because simply saying, encryption enabled on my DynamoDB table is true, that's great, but it's not the entire story. And what this will do is two things, right? What we've observed is it creates transparency across the security engineering teams to say, are these controls, is this automation working? Are these issues being caught? And then, as you get momentum and traction, then you can think about, okay, well, how do we deliver and fit into the developer workflow like I was touching on earlier? So, again, I've talked about this, right? There's, the last thing I want is yet another dashboard, right, that I have to manage to understand, hey, what other security issues that I should look for? And there's an inherent tool fatigue across the board, right? We're all experiencing it. And the more security can be delivered into the ecosystem in which the developers are operating, the more quickly we can gain visibility into the security issues and the fewer issues that we're going to encounter post-deployment, right? So that's important. And, I'll say one of the biggest things is when you start implementing some of these controls and guidance, one of the key things to be mindful of is how do you actually measure and create feedback loop, right? Because let's say that you started codifying some of your controls, you've incorporated them early in the CI/CD pipelines or even earlier by incorporating them into, as an example, into the IDEs through test-driven development. But it's important to understand, okay, are these controls that I'm codifying and automating, are they being effective? Am I catching fewer issues post-deployment? And one of the ways to do that is to add monitoring post-deployment, but also do that through pen test and risk assessments. Because what you should start to see is your pen tests that you conduct release over release, sprint over sprint, are yielding fewer and fewer issues that you're identifying. And if you are continuing to see the same set of issues, then you know that you need to go back and work on those automated controls earlier to address them and update them. And what this will enable the teams to hopefully do is these feedback loops will really enable teams to get more engagement and get more buy-ins, because developers are not frustrated that I have to fix things post-deployment. I'm now adding more and more things into my backlog. Rather, I have these feedback loops. I have data points that enable me to address these issues early. And so, if I am thinking about, delivering security in this modern way, what does success look like to me, right? If I'm a security practitioner. So really, it's about how do we create that feedback loop? What are the metrics that we're tracking as a security organization in this modern security world? And really the key area is thinking about delivery time, right? So how quickly and frequently are my developers able to deliver the capabilities that they are? So if you think about where you are today, and as you start building the controls and these automated codified guidelines and guardrails up front in your process, you can measure deployment frequency as an example. So are my developers delivering multiple times in a release cycle versus maybe doing it once a month, as an example? What is the reduction in time to resolve the issues that I'm finding? So I talked about, well, we can do pen tests to understand what new issues are popping up. What are the issues that we're reducing? How many new automated tests are we building, or new automated guardrails that we're building based on the issues that we caught, right? So that should lead to reduction in time, both in terms of delivering security, but also in terms of identifying security issues later, right? So velocity of delivery, velocity of resolution, security cost avoidance and reduction, which is hard to track, but these are some of the ways to track. And I think, the last but not least that I'll talk about is collaboration. It's important to also to track how are teams collaborating, right? Because yeah, we can all say, I can say standing here that security needs a seat at the table, they need to get engaged early in the development lifecycle, but how do we measure that? Well, we can measure that by, again, how many classes of the same security issues that we're finding again and again and again. Maybe we're finding those again and again and again because security wasn't there early on to bridge the gap between development and security. Are there security and development champion programs, right? So think about, if I think about security champions into the development teams or into these teams, are security practitioners engaged early on and throughout, not just early, but throughout the entire life cycle of delivery, from not only design, but to code, to build, test, and deploy. So these are key metrics to track. And so what I want to show you, right, and share with you is a framework on how you can actually take steps concretely to move towards this new way of delivering security. And the first point is really to assess your current state, right? You need to understand where you are today, and that's critical. So I talked about, let's get a buy-in from leadership. That's important. But part of getting a buy-in from leadership is to really assess where you are as an organization today. Is security really involved? When are they involved? Are they engaged? When are they engaged? Are they engaged at the build phase? Are they engaged today at the post-deployment phase? What level of governance does security have into SSDLC? What level of influence and visibility do they have? Are developers incentivized and trained through training programs to better understand and gain an understanding of how security applies and where there are some of the key areas that they should focus on as they're delivering cloud-native architectures? Security you should assess, how does security actually gain visibility post-deployment? So if the development team is codifying their architectures, are they actually bypassing governance to create drift because they're now going through ClickOps approaches and changing that architecture without security having that visibility? So the framework starts with getting your initial assessment, and then really start with where you want to end, right? So you want to focus on, well, where do I see as an organization us being a year from now? So let's say that you set some goals and you say, hey, here are the level of controls and compliance that we want to achieve and automate. Then work backwards to say, what does my 30-day, 60-day, 90-day plan look like, right? And this is something we've done, and what we've seen across both our customers and internally is, if you start with sort of end in mind and build out that 30, 60, 90-day plan, then again, it gives you a nice little feedback loop with your leadership to share, to say, hey, here are the gaps we saw in the first 30 days that we've identified in our current assessment. In 60 days, we intended to automate maybe 5 controls out of the hundreds that we had. And here's where we ended up within 90 days, right? What are the areas that we need improvement? And then continuously work towards, again, kind of that feedback loop is really critical, right? That feedback loop comes from people, but it also comes from processes and technology, right? So all 3 people, process, technology feedback loops will feed into your plan. And I'm happy to share this post conversations. If you have any questions, feel free to drop me a note at hello@oak9.io or info@oak9.io. I promised I'll make it quick, reserve some time. Happy to take some questions. If not, we can break early for lunch. Thank you very much.